Okay, we continue our lecture reversing the order of integration. What does it mean by reversing the order of integration is change from type 1 to type 2 double integral or vice versa. Okay, look at example. Okay, sketch the region of integration for the integral. Okay, so here we have x. So here will be x equals to y squared. Up here, x equals to y. Okay, next we integrate with respect to x to y. So we have y equals to 0, y equals to 1. Okay, now we are going to sketch our graph of y equals to 1, y equals to 0, x equals to y, x equals to y squared. Okay, so y equals to 0 is the x-axis. Okay, so x-axis here is our y equals to 0. Okay, y equals to 1. Okay, if the value 1 here is 1. Okay, so y equals to 1 is this line. Okay, label y equals to 1. Okay, next x equals to y squared. X equals to y squared. Okay. Okay, here is our graph. Y equals to x equals to graph here, label label our graph x equals to y squared. Okay, and then x equals to y is the straight line. Okay, when our x equals to 1, our y equals to 1, it should be here. Okay, and also here. Okay, and then draw a straight line from here. Okay, so our shaded area here is the region of integration. Okay, so we sketched already our region of integration. Next, we have to write an equivalent integral with the order of integration reverse. Means that we have okay, I draw once again. Okay, just refer to this one. Okay, now we are going to have okay, before this we have a parallel horizontal parallel line. Then we have to change into vertical parallel line. So okay, so here look at our parallel line, which is vertical lines. Okay, so blue in color here. Okay, so this one is x equals to 0, which is y-axis, and this line is x equals to 1. Okay, because we know that the point of intersection here is 1, 1. Okay, so now we are going to proceed to reverse. Okay, write again our double integral, but now we reverse the order of integration. So dx dy becomes dy dx. Okay, since we have y here, so here should be y equals to what from what here. Okay, and then we have x here. Okay, the outer integral here will be x equals to what, to x equals to what here. Okay, okay, so we know that our x we get from parallel line, the blue lines here, which is x equals to 0, okay, to x equals to 1. Okay, from smaller value to a greater value, okay, in that direction. Okay, so for y equals to here, we have to look at our graph in between these two blue lines here. So we have the upper one is x equals to y squared, right? Okay, so now we have to change our x equals to y squared, so that the subject becomes y equals to square root of x. Okay, so here will be square root of x. Okay, okay, so for lower graph here we have x equals to y. Okay, so change the subject, should be y equals to x. Okay, so here the lower one, y equals to x. Okay, so we have reversed our order of integration already, so just put the hashtag here. Okay, here is our example, here is our answer. Okay, we don't have to evaluate this integral, depends on the question here. So in our example here we have okay, we have to write an equivalent integral only. Okay, that's all.